Okay, so we learned two new topics, that was matrix addition and matrix multiplication. So now if we learn anything new, we need to also learn about its properties. So let's see the properties of matrix addition and matrix multiplication. Now what's the commutative property? When we talk about anything new, addition, subtraction, multiplication that we have learned, so we come across a word commutative. So here we would be talking about commutative property. Now 2 plus 3 is equals to 3 plus 2, and 2 into 3 is equals to 3 into 2. So normal addition is commutative, normal multiplication is commutative. So same way matrix addition is also commutative. But please do remember, matrix multiplication is not commutative. AB may or may not be equal to BA. As I told you earlier when we were doing the questions also, AB may or may not be equal to BA. Sometimes AB and BA are same. Sometimes AB gives you a different value and BA gives you a different value. And sometimes what happens? AB is possible and BA is not possible. And sometimes BA is possible and AB is not possible. For example, here A is a 2 into 2 matrix, and here B is what? A 2 into 3 matrix. So here if you see, AB is defined but BA is not defined. I can perform AB, I can get a value for AB, I can get AB as a 2 into 3 matrix, but BA is not possible in this particular case. Now suppose I ask you a question. Give me an example of a matrix in which AB and BA are always equal. I'm asking you this particular question, that you have to give me an example of a matrix in which AB and BA are always equal. When does this particular thing happen? This happens only in case of diagonal matrices. Please do remember, in case of diagonal matrices, AB and BA would always be equal. For example, if A is 1, 0, 0, 2, this is a diagonal matrix, and B is 3, 0 and 0, 4. So this is again a diagonal matrix. Now when I perform matrix multiplication, I get AB and BA, both the sides you can perform and see. You would get AB as 3, 0, 0 and 8, and you would get BA also as what? 3, 0, 0 and 8. So please do remember, this is a very commonly one marker question and nobody knows also. This is in the blue box of the textbook. As I have earlier also told you, textbooks are your Bible. So you don't read through the textbook, and there are blue boxes in the textbook. So it is given in the blue box of the textbook that when are any two matrices always equal. So please do remember, AB and BA are always equal only in case of diagonal matrices. So this is a commonly asked question. Let us move ahead. Now we have the associative property. Please do remember the associative property. Now what's the associative property? You all know matrix addition and multiplication both are associative. That is, A plus brackets of B plus C is same as A plus B plus C, and A into BC is equals to AB into C. So please do remember, although matrix multiplication is not commutative, but it is still associative. Please do remember, this is a very peculiar property of matrix multiplication, that it is not commutative, but it is associative. So A into BC is equals to AB into C. Then we have the distributive property, that is A times of B plus C is equals to what? AB plus AC, and A plus B of C is equals to what? AC plus BC. Now we have the existence of the identity element. Now this is something very important. Identity element. What is the identity element for matrix addition? This is a commonly one marker question which is asked. What is the identity element for matrix addition? So for matrix addition, the identity element is the zero matrix or the null matrix of the same order. So A plus O is equals to A, which is equals to what? O plus A. Now, what about matrix multiplication? What is the identity element for matrix multiplication? Please do remember, identity matrix of the same order is the identity element for matrix multiplication. Now, this is something very important. It would be used further in inverse of a matrix also. AI is equals to IA, which is equals to A. Now, this is again a very commonly asked one marker question. What's the identity element for matrix multiplication? Ma'am, what is that? A into 1 generally, what all students do? A into 1 is equals to A. But this is wrong. When we do it in case of matrix multiplication, it would be what? AI is equals to IA, which is equals to A. So please do remember this. Please take a screenshot of all these. This was the properties of matrix addition and multiplication. You can note them down and write them. So I would request you to take a screenshot of this particular topic.